folks, here we go. Here we go. It's going to pop up in just a second. We're going to rock and roll. When it pops up, be ready to go, because we're going to go. In fact, I'm going to start reading number 16. The end of a pendulum travels 50 centimeters on its first swing. Each swing after that travels 99% as far as the preceding one. How far the pendulum traveled before it stops. So we start with 50. The next one is going to be 50 times 0.99. The next one would be 50 times 0.99 times 0.99, and so on and so forth. And we're just going to keep going as long as we want. So this is a geometric infinite series. So I take the first term, 50, put it over 1 minus the rate, or the ratio, the thing I'm multiplying by every time, which is 0.99, which therefore is going to lead me to 50 over 0.01. 0.01 is the same thing as 1 over 100 multiplied by 100, so this is going to 5,000. The answer is 5,000 centimeters. It's going to go to 5,000 centimeters. Okay, number 17. Stay with each form is explicit or recursive. Find the first 5 terms. Well, you can notice that it doesn't say a sub 1 equals anywhere, so therefore this cannot be recursive. This must be explicit. The first 5 terms for an explicit, the first term would be 5 times 1, which is 5, minus 8, which would be negative 3. And then we're multiplying by 5, which means we're repetitively adding 5. Remember, multiplication is repetitive addition. So the next term in the sequence would be 2, then 7, then 12, then 17, just adding 5 every time. Okay, take a look at 18. Again, they do not say a sub 1 equals anywhere, so this is not recursive, this is explicit. Then you just take 1 and plug it in. 1 squared is 1, 1 times 2 is 2, 2 plus 1 is 3. Take 2, 2 squared is 4, 4 times 2 is 8, 8 plus 1 is 9. Take in 3, 3 squared is 9, 9 times 2 is 18, 18 plus 1 is 19. Put in a 4, 4 squared is 16, 16 times 2 is 32, 32 plus 1 is 33. Put in a 5, 5 squared is 25, 25 times 2 is 50, plus 1 is 51. Folks, you're done. Okay, next one, number 3. So it has negative 3.5 to 6.2 to 15.9. Well, to get from here to there, I would add, see if I was adding, I'd add a 0.7 and then 8. I would add 8.7. Let's see if getting from there to there is also adding, actually that's a 9.7. Okay, let me make sure. So if I take 6.2 and I subtract a negative 3.5, okay, try that again. 6.2 minus a negative 3.5 gives me 9.7. That sounds like a full class ticket coming at you. And then from here to here is another 9.7, so I'm adding 9.7 each time. So this is arithmetic. They want me to state the common difference. So that's the common difference is 9.7. And that's all they want. We're done. Okay, to get from 4 to 11, I would again add 7. 11 to 19, I would add 8. 19 to 28, I would add 9. Okay, so I know it's not arithmetic, so arithmetic is out. Geometric, 11 divided by 4 is 2.75. 19 divided by 11 is 1.72, so geometric is out. Therefore, this is neither, and there is no common ratio or difference. So I was just taking like 28 divided by 19, 19 over 11, 11 over 4, and these did not equal the same. These were not equal. Since therefore that's true, there is no geometric thing here. So now from 35 down to 27, that would be like subtracting 8. 27 to 19, subtract 8. 19 to 11, subtract 8. So this is arithmetic. And the common difference is negative 8. Here, from negative 4 to 16. Oh, but then to negative. Okay, so I'm not adding the same number every time, or I'll just go positive. So I must be multiplying. So I'm multiplying by a negative 4. This is multiplying by a negative 4. And then this would be multiplying by negative. Okay, so this is geometric. So I'm multiplying by negative 4 every time. Okay, hold on a sec, folks. Sorry. Sorry, I can't talk right now. Okay. So at this point in time, we'll go with, it is geometric, and the ratio, common ratio, is negative 4, because that's what I'm multiplying by every time. Determine if the sequence is arithmetic geometric. Find the 16th term. Sure. So to get from 1 to 3, I would add 2, but 3 to 9 is adding 7, so arithmetic is not true. 1 to 3 is multiplying by 3. 3 to 9 is multiplying by 3, so geometric is true, so this is geometric. If it is geometric, then I could find the the explicit equation by taking 1 times 3 to the n minus 1, and then I could just plug in 16 for n. So then if I plug 16 in for n, 16 minus 1 is 15, so I would take 3 to the 15th power. So let me grab my calculator here. I take 3 to the 15th power, which is that big number right there, times 1. So my answer is 14,348,907. That's the answer, number 7. Number 8, get from 5 to negative 2, I would subtract 7. Negative 2 to negative 9, subtract 7. Negative 9 to negative 16, subtract 7. So I'm subtracting 7 every time, so this is arithmetic. My equation explicit would look negative 7n plus, looks to me like I go plus 12, because if I plug in a 1, then I would get negative 7 plus 12 is 5, that's right. Now I want the 16th term, so I take negative 7 times 16 plus 12. So in my calculator, I take negative 7 times 16 plus 12, and I get out negative 100. That is the 16th term. Okay, number 9. So get from 7 to 12, I add 5. 12 to 17, add 5. 17 to 22, add 5. So I'm adding 5, so this is arithmetic. So that's going to be 5n, and then to get, this is my first term, so to get to 7, if I plugged a 1 in here, I get 5. 5 plus 2 is 7. There's my explicit. So then I just take and I put 16 in for n. So I get 5 times 16 plus 2 again. Calculator. 5 times 16 plus 2. I get 82. There it is. To get from 40 to negative 20, I would subtract 60, but from negative 20 to 10, I was not another subtract 60, because this is not arithmetic. 40 negative 2, I could multiply by negative 1/2. Negative 20 to 10, multiply by negative 1/2. Okay, this is geometric. Multiplying by negative 1/2, so that negative 1/2 to the n minus 1, and then put 40 right here. That's the explicit. Put in 16 right here for n, so it gives us 40 times negative 1/2 to the 16 minus 1, which is 15. Take your calculator, plug it in, 40 to the, 40 times parentheses, negative 1 divided by 2 to the 15th power. Oh dear. Calculator didn't like what I did there. We'll delete that. Hit enter here, and I get negative 0.00122, but I just need negative 0.001, call it a day. Okay, turn the page. Number 11. Determine if the sequence is arithmetic or geometric. Write the explicit recursive formula. So from 9 to 14 is adding 5. 14 to 19 is adding 5. So this is arithmetic. So if it's arithmetic, the recursive would look like this. A sub 1 equals 9. A sub n equals a sub n minus 1 plus 5. The explicit equation would look like this. For me, 5n plus 4. If If you want it the other way, you could have 9 plus 5 times n minus 1. Either of these would work. Okay, from negative 5 to 20 back to a negative 80, I must be multiplying by negative 4. And sure enough, I am multiplying by negative 4. If it alternates back and forth between positive and negative, you got to be multiplying by a negative. So this is geometric. So again, recursive, a sub 1 equals negative 5. A sub n equals a sub n minus 1 times a negative 4, or negative 4 times a sub n minus 1. Explicit equals, again, if I say this is the first term, then I would write it like this. Negative 5 times negative 4 to the n minus 1. That's the easiest probably way to do it. You could, of course, do negative 5 times negative 4 to the n if this n was the 0th term. Or you could do negative 5 over negative 4 times negative 4 to the n if it's the first term, which would be a positive 5/4. Any of these three here would work as long as you knew this was 0 for the first term, this is 1 for the first term, this is 1 for the first term. Take a look at 13. 1/3 to 1/9, 1/27. Okay, I'm multiplying by 1/3 every time. So this is geometric. So the recursive would say this, a sub 1 equals 1/3. A sub n equals a sub n minus 1 times 1/3, or 1/3 times a sub n minus 1. Explicit. We're just going to do this first one here. So 1/3 times my, because that's my first term, times my ratio, which is 1/3, is what I'm multiplying by every time, to the n minus 1. Done. 12 to 17, add 5. 17 to 22, add 5. 22 to 27, add 5. So this is arithmetic. 5n plus 7. If this is my first term, 5 times 1 is 5. To get to 12, I'd add 7. Or you could have written 12 plus 5 times n minus 1. Either way works for me. For explicit, I forgot recursive. So recursive is going to be a sub 1 equals 12. A sub n equals a sub n minus 1 plus 5. Done. 5 to 1 minus 4. 1 to negative 3 minus 4. Negative 3, negative 7 minus 4. Arithmetic. Recursive arithmetic says a sub 1 equals 5. A sub n equals a sub n minus 1 minus 4. Explicit, negative 4n plus 9, or 5 plus negative 4 times n minus 1, or 5 minus 4 times n minus 1. Perfect. To get from 100 to 20, I would subtract 80. 20 to 4 is not subtracting 80, so it's not arithmetic. Let's see. 4 divided by 20 is 1/5. 20 divided by 100 is also 1/5, so this is geometric, with 1/5 being our ratio. So the recursive says a sub 1 equals 100. A sub n equals a sub n minus 1 times 1/5. Explicit would equal 100 times 1/5 to the n minus 1. Done. Rewrite the series using summation notation, then find the sum. So summation notation means we have to have sigma. 66 to 72 is adding 6. 72 adding 6. So this is arithmetic, so I'm going to do n equals 1. I have to figure out how many terms that is. To do that, I'm going to find the explicit equation. So for me, 6n plus 60 is my explicit equation. At that point in time, I now take 6n plus 60, is equal to 108. Subtract the 60. I get 6n equals 60, no, not 68, sorry, 48. Divide by 6. N equals 3. Sorry, that's a full class ticket. N equals 8. I don't know. Sometimes. So that it is. There is the summation notation. To find the sum, since it's arithmetic, I take the first term, which is 66, plus the last term, 108, divided by 8 over 2, which is 4. 108 plus 66 be 174 times 4. 4 times 4 is 6. Bring up to 1. 4 times 7, 28 plus 1 is 29. Bring up to 2. 4 times 1 is 4 times plus 2 is 6. 696. So there's the sum. and move to 18. To get from 5 to 15, I add 10, but 15 to 45 is not adding 10, so it's not arithmetic. I can multiply by 3, multiply by 3. Okay, this is geometric. So, summation notation, n equals, you can still do 1. That just means, though, you're going to have 3 to the n minus 1, and it's going to be 5. Determine how many terms there are. Take 5 times 3 to the n minus 1, set that equal to 98,415. So divide by 5 first. You get 3 to the n minus 1 equals, so in my calculator, I'm going to take 98,415 and divide by 5. I get 19,683. I now take log base 3 to get rid of 3 to the power. That's n minus 1 equals. So now I go to math. Down here to my cool log base button. I can now type in 3 of 19,683. Pumps out 9. Hence n equals 10. So this is going to be 1 to the 10. So I'm doing 10 terms. Now to find this one, I use the equation a sub 1 times 1 minus r to the n over 1 minus r. So a sub 1 in this case is 5 times 1 minus the common ratio, which is 3 to the 10th, because there's 10 terms, over 1 minus 3. I just put it in my calculator just the way it looks. Take 5 parentheses 1 minus parentheses 3 and a parentheses to the power of 10 and a parentheses divided by parentheses 1 minus 3 and a parentheses, and hit enter. I get 4.979. 4.979. Oh, hello. Something is wrong. Big time. Full class ticket. Look at this up here. It stayed in the exponent. You gotta be careful. Careful, careful. Careful, 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 my friends. Careful. Divided by parentheses 1 minus 3 and parentheses. Here we go. That looks better. 147,627.5. There's your sum. Be careful, baby. Okay, number 19. It says determine if it's geometric arithmetic. Evaluate it if it has. If it doesn't, say why. So this is arithmetic. We can see that because we're multiplying by 2, which means repetitive addition. Since it's repetitive addition, it'll be arithmetic. I then can find the series, the sum, because it is infinite. It is finite. Another full class to keep. So I need the first term. So I plug in a 1. 2 times 1 is 2, minus 3 is negative 1. Plus the last term, plug in 11. 2 times 11 is 22. 22 minus 3 is 19. And then there's 11 over 2 terms. Negative 1 plus 19 is 18. Times 11 over 2. 2 goes into 18, 9. 9 times 11 is 99. There's the sum. 1 to 2 is plus 1. 2 to 4 is not a plus 1, so it's not arithmetic, but it is timesing by 2 every time. And look at these numbers getting bigger, but it does stop, so it does have a sum. This is geometric, though. So I'm going to take the first term times 1 minus the ratio, which is 2, to the 8th term, over 1 minus 2. So handy dandy calculator. I'm going to take 1 parentheses 1 minus parentheses 2 to the power of 8 divided by parentheses 1 minus 2. And I get 257. Done. Okay, I'm going to have to finish this up later, guys. So I'll finish that last page later. Have a good day. Hope that helped out. And we will talk to you a little bit later today.